Hey guys, so today I'm going to show you a path in Franklin Lakes, New Jersey and how to find the length of it using calculus. Like I said, the goal of this project is to determine the length of a path, which you can see right over here, that I usually jog or bike around. I'll determine this length using calculus, specifically the arc length formula. The first step of this project was to determine a path on Google Maps. I chose this sort of bunny shape and then split it up into arcs 1, 2, 3, and 4. I then created an X and Y axis to create points that can be plugged into the Desmos regression software, an online program, to create graphs of the arcs. After that, I used the arc length formula to calculate the length of the curves using the formulas that the regression software generated. These straight lines over here and over here can be measured using the ruler tool on Google Maps. I used the formulas for each of the curves, added up the results, and then compared this final calculated length to the value that Google Maps gave me. So over here, you can see the points that I found using the ruler tool for arc 1. I then graphed them and found this parabola and this equation over here. All four arcs on the map look like parabolas, so I just decided to try a quadratic equation for them all, and it worked. The r-squared value, which you can see over here, was equal to exactly 1, yay, which means this equation fit the graph perfectly. Once again, here are the points that I found using the ruler tool for arc 2 and the graph generated using the regression software. You can see the quadratic equation over here. The r-squared value is 0.976, so the equation is not as perfect as the first arc, but it is pretty close to 1, so it'll do. So here we have the points for arc 3. The third arc was graphed using the points here, and which resulted in this quadratic here. Once again, the r-squared value was 1, so the quadratic is a perfect fit. Last but not least, we have the fourth arc graphed over here. These points resulted in the quadratic equation you can see over here. The r-squared value is 0.862, which is not as close to 1 as the other arcs, but you can't always be perfect. The value itself isn't that far from 1, so the quadratic is a decent fit. So this slide shows where the calculus comes in. Over here we have the arc length formula, which is ds is equal to radical 1 plus the derivative squared. Here you can see how I calculated each arc's length using this formula. I found the derivative on my graphing calculator based on the quadratic shown on the previous slides. The upper and lower limits were also found using the graphs on the previous slide. Down here, you can see how I added up each of these lengths. These numbers, 30 and 30, were shown from the straight lines on the path that I showed before. Adding up all these arcs gave me a grand total of 642.331 feet long. So over here we can see how accurate the arc length formula was for this particular path. The calculated value, as I mentioned, was 642.331 feet. The measured value from Google Maps was 529 feet. There was a 21.42% error, which is not as small as I would have liked. It is possible that I may not have been exact enough when I was calculating the coordinate points on Google Maps using the ruler tool, or that the quadratic for the fourth parabola may not have been the best fit. Overall, the arc length formula did give a decent estimate of the length of the path. So that's my path in Franklin Lakes. Thanks so much for watching.